Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video on trigonometric ratios. So this is where we introduce trigonometry. So we've seen Pythagoras. Pythagoras is a way for us to find an unknown side in a right-angled triangle. Well, trigonometry is similar. We can find unknown sides and unknown angles in a right-angled triangle. It's just we use trigonometry and Pythagoras at different times. If you remember, Pythagoras, to find an unknown side, you needed the other two sides. We'll look at finding sides and angles in subsequent lessons. It turns out to find a side using trigonometry, you need one angle and one side. So trigonometry kind of complements Pythagoras. You use them at different times to find unknown sides, or with trigonometry also unknown angles. But before we get on to all that, we need to know the trigonometric ratios. So once again, we're looking at right-angled triangles. You're probably sick of seeing them by now. So we have a triangle like this. Now what we're going to do is we're going to mark an angle, and I'm just going to call that angle theta. Doesn't matter exactly what the value of theta is. I know it can't be more than 90 degrees, but we'll just leave it as theta for now. So to understand the trigonometric ratios, what we need to do is we need to label our sides appropriately. So we label them in relation to the reference angle. So the reference angle here is theta. We want to label the three sides, and we always label the three sides as hypotenuse, adjacent, and opposite. You already know what hypotenuse means. We learned it in Pythagoras. So the hypotenuse would be this side here. The hypotenuse is always the longest side. It always faces the right angle. So that hasn't changed. In any right angle triangle, the hypotenuse is the longest side and faces the right angle. So we now need to label the other two sides. We label them as adjacent and opposite. So adjacent means next to. So the adjacent side is the one next to the angle, in this case next to theta, other than the hypotenuse. The adjacent and opposite are always shorter sides. So that's the adjacent. Opposite means facing. So the opposite side is the shorter side that faces theta. The adjacent side is the shorter side that is next to theta. So the hypotenuse is always the same, but the opposite and adjacent switch around depending on where theta is. So if I draw the right angled triangle so it's facing the other way, and now let's call this angle theta. This side here, will still be the hypotenuse, the longest side facing the right angle. That really hasn't changed. But now the opposite side will be over here. It's the shorter side facing theta, and the adjacent, I'll just call it ADJ for short, is the shorter side next to theta. So it's really important that we are able to label the sides appropriately. Otherwise, we're not going to understand the ratios. So please make sure you ask me if you have trouble labeling the sides. We always label them hypotenuse, opposite, and adjacent. The hypotenuse is always the longest side facing the right angle. The opposite is the shorter side facing the reference angle, theta, and the adjacent is the shorter side that is next to theta. So let's go through what the ratios actually are. So there are three ratios that we have to know. So let's say this is a right angle triangle here, and I'm going to call this one theta. So this side here will be opposite, I'll call O. The shorter side next to theta is the adjacent side A, and then H is the hypotenuse, which is the longest side. So there are three ratios you need to know. Firstly, the sine ratio, or sin for short. We always have to write it with an angle because the value of the ratio changes depending on the angle. So sine theta is the ratio of the opposite to the hypotenuse. The cosine ratio, the second ratio you need to know, is the ratio of the adjacent to the hypotenuse. And the third ratio you need to know is the tangent ratio, or tan for short. It's the ratio of the opposite side to the adjacent side. So the way people usually remember this is the acronym SOHCAHTOA. So this stands for S is for sine, or sin for short, is opposite hypotenuse, as we put here. Whichever one comes first goes on top. So sin opposite over hypotenuse. C for cos is the adjacent over hypotenuse. So adjacent comes first, it goes on top. And then the tangent ratio is the opposite over the adjacent. Once again, opposite comes first, so it goes on top. So what exactly does this all mean? Well, let's look at an example now with numbers, so hopefully this will become clearer. So please pause and copy this down if you need. So let's say we have this right angled triangle here with sides 3, 4, and 5. So the sine of this angle, whatever this angle is, it doesn't really matter. We just know it's less than 90 degrees. Could be 30 degrees, could be 40 degrees, whatever. The sine of this angle is the opposite side over the hypotenuse. The cosine ratio, the cos of that angle, is the adjacent over the hypotenuse, and the tangent ratio is the opposite over the adjacent. So what we're doing here is we're just getting to know the ratios so that in subsequent lessons we can use them to find unknown sides and angles. You just need to be comfortable with the ratios now. So what exactly is going on and why is this useful? Well, let's say we have now a right angle triangle and I'll give you an angle. So let's say this angle here is 30 degrees. So if you put on your calculator sin 30, what you get is the value 1/2. So sine 30 equals 0.5. If you don't get 0.5 when you put in sine 30, you're probably in the wrong mode and you need to talk to me. So we know, for example, that sine 30 equals 1/2 or 0.5. So that means that the opposite side over the hypotenuse is 1/2. This is a ratio, something divided by something. So what it's saying is that if this angle here is 30 degrees, then this side, which is the opposite side, will be exactly 1/2 of this side. If you fix the angle here, there's only one value that the ratio can take. So that means if this side here was 2, this side here would be 4. It would be double it. It means if this side here, let's say, was 3 instead of 2, then this side here would be 6. So basically, if I have this 30-degree angle and I know the opposite side, I can find the hypotenuse. Similarly, if I know the hypotenuse, I can find the opposite side. So let's rub this out. So let's say I told you, for example, that the hypotenuse was 8.4. Because sine 30 is 1/2, the opposite side here would be 4.2. Cosine 30 equals 1/2. This opposite side must be 1/2 of the hypotenuse. That's how we're going to use this in subsequent lessons to find unknown sides and angles. But let's look at one of the other ratios now. So let's get rid of these. So let's keep the angle at 30 degrees. If I go to my calculator, assuming it's in the right mode, degrees mode, and I put in cos 30, I get an irrational number. It goes on forever and ever. That number, cos 30, if you put it on your calculator, is approximately 0.866. So remember, cos is the ratio of the adjacent to the hypotenuse. So it's the ratio of this side to this side. Okay? So what it means is if this angle here is 30, then the adjacent side is about 87% of the hypotenuse. So if the hypotenuse was, say, 10, then the adjacent side must be, there's only one value it can take, it has to be about 8.66, okay? So you could do the same with tan. If I put tan 30 on my calculator, I again get an irrational number, and that usually happens in trigonometry. It's about 0.577. So that, remember, tan is the ratio of the opposite side to the adjacent. So it is saying if this angle here is 30, the opposite side must be about half, just over half of what the adjacent side is. So let's say, for example, that this side here was 12. So then, that's the adjacent side, by the way. So then the opposite side would be about 0.577 times that. So it would be about 6.93 or thereabouts. So that's what happens. If we fix the angle, if we know the value of the angle, that determines the ratios of the sides in the triangle. If we change this to another value, we get a different value for the ratios. If I change it to, say, 45, so I know, for example, that sine of 45, if I put that on my calculator, so once again, you've got to be in the right mode, let me know if you're not, you should get about 0.707. So sine is the ratio of the opposite side to the hypotenuse. So if the angle here was 45, this opposite side would be about 70% of the hypotenuse. That's what we're saying here. If you know the value of the angle, the ratio of the sides is fixed. You can use your calculator to find the value of the ratios of sides, and we can use that to find unknown sides. But what I want you to get out of this video today, you need to be able to label the sides appropriately. When you're given an angle like this, you need to be able to label them as opposite, adjacent, and hypotenuse. And you need to be able to identify the sine ratio, which is the opposite side divided by the hypotenuse. You need to be able to identify the cosine ratio, which is the adjacent side divided the hypotenuse, and also the tangent ratio, which is the opposite side divided by the adjacent side. So that's what we need to just understand, what these ratios actually are, and then when we get that, we'll be able to use them to find unknown sides and unknown angles in subsequent lessons. All right, this is a very abstract concept that's new to you, so please make sure you ask if you need any help. Thank you for watching. This has been the luckiest maths teacher in the world. Have a great day.